Hi! I will present the RS team and their project. The team members are Rosu Christian and Sucala Paul. The project is about designing an active system that would work as an accident deterrent, available to the masses in order to drastically reduce car accidents caused by human error. According to National Police Service, 75% of all reported collisions appear at speeds of up to 30 km per hour. In half of this, people experience severe spinal cord injuries or broken neck. Furthermore, in the past years the people that die in traffic collisions tend to outnumber those who die of cancer, for example. Most of them are caused by external interference, bad driving, inattention or failure to stay awake behind the steering wheel. And obviously, no one wants to experience this. The consequences of an accident can be very stressful, cost a lot of time, money, and in many cases end up in severe injuries or death. Our system uses a pair of sensors mounted in the front of the car. These sensors can detect obstacles up to 60 meters ahead. If the driver fails to react in due time, the system will automatically apply the brakes. The brain of our system is the processing unit based on two microcontrollers. By working in parallel, the chances of failing are minimized and so the reliability is ensured. This unit processes the feedback signal coming from all the sensors mounted on the car. The system has a long-range sensor capable of making 3 complete scans per second in front of the car, and also an ultrasonic short-range one with a greater accuracy, operating at low speeds. Among these environmental sensors, the system also has internal sensors that constantly collect data in terms of vehicle speed and acceleration, all to be processed by the embedded computer. Something interesting. By measuring the driver's pulse with a sensor integrated in the steering wheel, the system can adapt to many situations according with the driver's general state. On the other side, the central unit communicates with the motion control module, the part of the system that sends the control signal to all the mechanical actuators, according with the sensor state. Before that, it goes through an amplifier that takes the low-stage signal and transforms it into the final command. The feedback signal helps reducing the errors that would occur in a simple control. Stepper motor throttle control. Circuit diagram and layout. Main characteristics presented. Dynamically controls the acceleration on our test vehicle. Takes automatically control over the acceleration when an emergency occurs and the system applies the brakes. Takes partially control over the car's drivetrain. It is designed in such a way that the acceleration and the brake module cannot be simultaneously activated. Accelerometer module. Circuit diagram and layout presented on the right. The module helps the system decide whether a brake action is unexpected, then the system can provide additional braking force, or partially take control over the acceleration, to prevent the collision. The microcontroller uses an algorithm that can interpret sideways acceleration, for determining the angle of the vehicle in a curve, and constantly adjust the sensor's angle of view. The brake actuator. Circuit diagram and layout. This part is the key for safety efficiency. It consists in a motor driver designed by us, with integrated circuit for feedback interpretation. The actuator is a powerful 12-volt, 350-watt electric motor. This module communicates with the speed measurement module, and can apply the brake by an algorithm that considers the vehicle's speed, acceleration and the approximate braking distance. The software platform consists in 2 parts. All the microcontrollers were programmed in Bescom programming language. The microcontrollers interpret the data coming from the environmental sensors, and also from the onboard sensors. Then it calculates the optimum way of dealing with a threat, or a problem. The software on the laptop enables us to visualize the parameters during tests and also make necessary adjustments. The first prototype was designed to be adaptable because we did not have a vehicle from the start. Because of money issue, we first tested the system on a 125cc terrain vehicle. After all the final adjustments, we will design and fabricate a much more compact version of this product that will actually be mounted into a car. So, this was our project review, with the progress made so far. See you in Bucharest at Infomatrix 2010. Goodbye.